It just means you're stopping at a certain point. Taylor polynomial just means you're stopping at a certain point as opposed to a Taylor series. Explain why for any x we can choose an n such that, what does this equal? This is the error, right? The error, so it doesn't tell you how far we're going, but it says, okay, no matter what we choose for x, we can always get as close as basically get as small as we want for the error. Does that make sense? So the error, the amount we are away from the actual value depends on x and n. Remember that, everybody? It depends on how many terms we have and the x value we have chosen. It depends on those two things. What this is telling us is if you choose an x for this Taylor polynomial, I can go far enough into the polynomial to always get that close. So here's the thing. You start building, if you were to build this polynomial, we know that f of x, the Taylor polynomial, is cosine x, right? So what's f prime of x?
Negative sine of x.
Negative sine of x, right? So what's f double prime of x? Negative cosine x. And you've done this many, many times. F triple prime of x is what? Sine of x, right? So you know that fnx, do you agree this, the nth derivative is going to be plus or minus cosine x or what? Do you agree with that?
Yes.
Okay, so what was that definition we had? We know that f of x minus Pn of x has to be less than m over what? N plus 1 factorial x minus 0 in this case because it's around 0 to the what? Do you agree with that?
Yes.
Okay, so here's the thing. You asked me, like, what's the interval? What's the interval? What's the interval? They don't specify here, but here's the thing. What do you know? You know that plus or minus cosine x or plus or minus sine x, both of those are always less than or equal to what? They're always less than or equal to 1, no matter where you are. Do you agree? So what m value should you choose? Let m equal 1. If that's the case, you now know that this right here has to be less than or equal to what? It's equal, right? Is it equal? In the definition, do you remember? It's equal, right? Is equal to what? 1 over n plus 1 factorial times x to the what? Do you agree with that? So let's simplify this a little bit. What do you end up with? The absolute value of n plus 1 all over what? N plus 1 factorial. So here's the thing. X is static, right? You choose the x value first. How small can you make this? X is static. N can go where? As big as you want it to go, right? So how big can you make that? Sorry, how small can you make that? How small can you make this? You can make this as small as you want. Do you agree? So what can you always make it less than? You can make it less than 10 to the what? That was arbitrarily chosen. Could I have chosen 10 to the negative 10th? Sure. If you choose an x value, like pick any x value, Seema. Like you can make x big or small. It doesn't matter, right? You can always pick an n value that will make that smaller and smaller and smaller and smaller and smaller and smaller. We can always choose it because n can be as big as we want it to be. So you can always choose an n value that's going to be way, 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 way bigger than x. Way, way, way bigger. And how powerful is the factorial function? It's extremely powerful, right? Well, like, oh, what happens if x is a billion, right? Well, n could be what? Quintuple trillion, right? How big is quintuple trillion factorial compared to that to the bit? It's going to be much, 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 much bigger. Do you remember that? We proved that with L'Hopital's rule, like factorial really kicks ass when it comes to size. It does. Does that make sense? What was the key here? What was the whole key? It's right there in the middle. What was the whole key to this problem?
It's always equal
less than 1. That's the key, Erica. Yes. Okay, so you also wanted to see 14. My question for 14 is, did you do 13?
I read it.
See, for what does 14 ask? Oh, I didn't put it in there. Sorry. Sure. That's fine. Let me go back to this. So you want to plug this in? Sure. So this one, it says, repeat it for that. Okay. I'll take this. I'll put it down here. So this is what it's asking right there. And we'll take this right here. Cut. And we'll put this in. So we're just going to do A and B. Okay. We can do that. Sure. This series, sine, what does sine do? Sine is an alternating series, right? It's positive, negative, positive, negative. So it's above and then it's below, and then it's above and then it's below, and then it's above and then it's below. So when you're subtracting that, when that theta cubed over 3 is being subtracted, it's going to be under it. And when theta cubed over 3 is positive, it's going to be over it. But that depends on if theta is negative to begin with or positive to begin with. So it's an overestimate when you are adding the theta cubed over 3, and that's going to happen when it's negative, because negative cubed is negative, and you have a negative in front of it. And then it's going to be an underestimate when it's theta is greater than 0. Does that make sense?
If you had plus theta to the 5th over 5, it would be opposite.
On this one. N equals 3, n equals 4, what is it going to be?
No. Well, 4.
So that's the real question here. It doesn't really specify, right? You'd be tempted to use 4, but if you use 4, is that present in the sine function?
Well, it is.
They use n equals 4 the next term. So the thing about this is, if I asked you for the 4th degree Taylor polynomial for sine, it's that one.
Yeah.
It's the same as the 3rd degree. So basically, go a little high, go higher if you can, because the error theoretically is better the more you go. So if n equals 4, what are you writing here? You know that E4 is going to be what? Less than m times what? Theta to the 5th all over 5 factorial, correct? Which is the same thing as m theta to the 5th over 120, right? Is that correct? Mm-hmm. So the question is, and we're looking at what's the interval? It's already circled, right? What's the interval? -1 to 1. So what's the biggest thing theta can be? What's the biggest thing absolute value theta can be? On that interval, it's 1. Are we good with this, everybody? It's 1. So what is this? We know that that's going to be, you could say less than or equal to just m over 120. Do you agree with that? Okay, so then we have to find an m value, right? So we're looking for f5 theta less than or equal to m for what interval? -1 to 1. What's the 5th derivative? I'll just tell you, it's cosine. It's cosine. It goes back. It's cosine of theta. So what's that going to be? What's our m value going to be? Yeah, we're just it's 1. It's going to come up a lot, okay? With trig functions, you bounce between it, so you definitely know it's less than 1. So what do we think our max error is going to be? Yeah, so we think E4, the error 4, is going to be less than or equal to 1 over 120. Right there. That's what it is. Yes, this is challenging.